Hi, Varun Prakash. How dare you? Thank you. Uh, just so you know, starting next week, I'm going to be going back down to shorter dancing streams. But also probably like keep these at like 20 minutes. So probably like 40 minutes total, like when it goes to weekdays. But I might have to do less than that. It depends. Like after next week. Everything is very contingent on everything else. Okay, I think I'll get some reading because I was waiting for my timer. When it sounds, I'll start a 15-minute timer, and then I'll get some reading in. I'm glad you've been enjoying the live streams. It's been really fun. Alright then. Nothing like the present. 15 minutes right now. Okay, overloading and function templates. If you really want to go out on a limb and create flexibility in your application, you can use overloading with a function template. Remember, overloading a function means that you create two different versions of a single function. Really, what you're doing is creating two separate functions that have different parameters. That is, either a different number of parameters or different types of parameters, but they share the same name. Look at these two functions found in the function overloading and template example. Int absolute value int x if x is greater than or equal to 0. Hi, Jenna. Return x, else return negative x. Float absolute value float x. If x is greater than or equal to 0, return x, else return negative x. These functions are an example of overloading. They take different types of parameters. One takes an int and the other takes a float. Of course, you could combine these functions into a template. Template type name t absolute value, t x. If x is greater than or equal to 0, return x, else return negative x. But is this really any different? After all, you can use the following two lines of code either after the overloaded functions or after the function template. Cout absolute value int n inline, cout absolute value float x inline. We're assuming that n is an integer. This is C++. We're assuming that n is an integer and x is a float. However, the template is a better choice. First, if you use the overloaded form and then try this, you'll get a problem. Cout absolute value 10.5 inline. We know that 10.5 is a float. Therefore, the compiler should just call the float version of the overloaded function. However, the GNU GCC compiler that ships with code: blocks gives you this error message. error call of overloaded absolute value double is ambiguous. So much ambiguous. I remember getting those errors. Oh, I already know Dina. Ambiguous, but look, the message is saying absolute value double. Apparently the GNU GCC compiler thinks that our 10.5 is a double, not a float. And you can actually pass the double into either a function that takes an int or a function that takes a float. The compiler will just convert it to an int or a float, whichever it is. And because the compiler thinks that 10.5 is a double, it figures it can pass it to either version of the overloaded function. So that leaves you a choice. You can either cast it to a float or create a third overloaded version of the function, one that takes a double. Yuck. At least code : blocks gives you some clues as to the problem because the standard error information is note counted. Counts are int absolute value int note float absolute value float. Creating a template. I don't like that part. Creating a template is easier, and that brings us to the second reason the template version is better. If you want a new type of the function, you don't need to write another version of the function. But what if you want to overload a function template? That sounds kind of scary, but you could do it. The overloaded function template example shown in listing 5-9 contains an overloaded function template. Listing 5-9 overloading a function template provides even greater flexibility. How should I include IOStream using namespace standard, template type name T absolute value TX, C out using first inline. If x is greater than or equal to 0, return x, else return negative x. Template type name T absolute value T star x, C out using second inline. If star x is greater than or equal to 0, return star x, else return negative star x. Int main. Int n equals -3, C out absolute value, int n inline, float, star x pointer equals to float, -4.5, C out absolute value float, x pointer inline, C out absolute value float, 10.5, inline, return 0. Fake lava monkey VR. If you're actually a third grader, why are you not in bed, like sleeping in dreamland? That's what I would be if I was a third grader. Anyway, when we pass a pointer, as in the second call to absolute value in main, the compiler figures out that it needs to use the second version of the template, and just to be sure which version gets used and at what time during application execution, we threw in a C outline at the beginning of each function template. When you run this code, here's what you see. Using first 3. Oh, fine. No, this is just a programming code. I mean, a computer programming language. Using first 3, using second 4.5, using first 10.5. It's just C++. And this is C++ All-In For Dummies. This is the 3rd edition. This is written by John Paul Mueller and Jeff Cogswell. From the middle, what's my time? From the middle, okay, over 6 minutes, just a little. From the middle 2 lines, you can see that the computer did indeed call the second version of the template. Tip: you can make life a little easier by using a little trick. Most compilers let you leave out the type in angle brackets in the function template call itself. The compiler is smart enough to figure out what type of function to build from the template based on the types that you pass into the function call. Pretty wild. Here's an example, main, that you can substitute for the main in listing 5-9. Oh, okay. Int main, int n equals -3, see out absolute value in line, float star x pointer equals new float, -4.5, see out absolute value x pointer in line, see out absolute value 10.5 in line, return 0. In this code, replace absolute value int n with just absolute value n. When you run the modified listing 5-9, you see the same output as well as when you run listing 5-9. Templatizing a member function. When you write a template, when you write a template for a class, you can put function templates inside the class template. To people who were familiar with some of the early versions of C++, where templates appear was minimal, this seems a little shocking. But when the electrical current wears off, we all see that putting a template function inside a template class is possible. You simply declare a function template inside a class, as in the following. Hi, Lean and Swerve. I'm sorry you're having technical difficulties. I did your request, but I don't know if you got a chance to actually see that. Oh, before I start reading this part, I should mention Lean and Swerve. Starting next week, I'm planning on going down to shorter streams during the weekdays, because I think I'm doing way too much streaming during the weekdays and not getting enough sleeping, and that's not a good thing for me. So I'm probably going to have to just wait to take requests until weekend streams. Class my math public string name, my math string name, colon, name, a name, template, type name T, void, right, absolute value, TX, see out, hello. So string of audio, sorry about that. Name in line, if x is greater than or equal to 0. See out, x in line, else see out, native x in line. Waterway? Oh, George Washington, right. The right absolute value member function is a template. It's, oh, that's right. It's a template. It's preceded by the word template and a template parameter in angle brackets. Then It has a return type void, the function name, and the function parameter. When you create an instance of the class, you can call the member function, providing a type as need be, as in the following. Int main myMath inst equals string George inst.write absolute value negative 50.5 inst write absolute value negative 35 return 0. In the first call, the function takes a double because by default the C++ compiler considers negative 50.5 double. In the second call, the function takes an integer. The compiler then generates two different forms of the function, and they both become members of the class. Remember, although you can use function templates as class members, you cannot make them virtual. The compiler will not allow it. And the ANSI standard forbids. That's hilarious. They're like the ANSI standard forbids we say. Dramatic. I could appreciate that. Even from doing it. In fact, we tried it and code blocks just to see what friendly message we would get. Here it is. Virtual time is up, friends. Good, because I'm almost done with this chapter. Yay. Virtual, oopsie, can only be specified for functions. We guess by functions, it means actual functions, not function templates. So ends book 4, chapter 5. Chapter 6 will be probably tomorrow. And then let me see how many more chapters there are in book 4. Okay, that's not too bad. Okay, that's actually not too bad. Okay, great. Like, this is pretty much been my only goal, like, as far as, like, computer science related since I graduated. And it's finally making some progress. So chapter 6 starting tomorrow. And then chapter 7 is only 30 pages after that, 38 pages. And then it's going to be book 5 for, that's not very many pages, like 50 something. Well, between 615 and 681, that's only like under 70 pages. And then advanced C++. Either way, this is definitely at the level where there's more read than needs to be read, and that is really great. Okay. Well, thank you guys for tuning in to me read C++ All-In For Dummies. That's better. So I'm gonna go because it's late for me. It must be heck late for you guys. But another reason why I need to go down, maybe if I have shorter streams, I can do them earlier, because if it's a matter of I'm keeping you guys awake too late, then if I have shorter streams, streams, then I can have them done at a reasonable time. Yeah, I'm gonna do that. I'm trying to decide. I should eat something because technically I haven't like I kind of was like snacking a bit after work so I could make sure I had enough energy to and was like focused to talk with my cousin. But now I'm like kind of. I think I'll just have some salad again. That seems probably good. Okay, then I'll go ahead and do that. You also please, Ryan or Dina. So good night to you, Ryan or Dina, and good night, Lena and Swerve. And I think you're the only two here because I see two. So okay, great. Good night to you both, and looking forward to tomorrow, some Thursday throwback time, and some more C++ All-In For Dummies soon after that. And it's Thursday, so it's going to be an uninterrupted sort of day. The main thing is I'll get off of work at 3 something. Let's just say I might not get home till like 4:30. So we'll make it work with that because it just depends on traffic. All right. Well, thank you, Ryan or Dina. I really appreciate you spending like I know you were unemployed and stuff, but it just the timing worked out really well. Thank you, because I definitely needed to do something while I was waiting for things to improve with my boyfriend. So he seems to be getting in a better way. So that's good. But I was just suddenly having time on my hands. So I don't know. I appreciate you being here so often. But I understand. You gotta make sure that you're doing your A game with your new job. And also, I'm planning on cutting back and making things a little more manageable for me because I should have been in bed like an hour ago, asleep or on my way to Dreamland. So I gotta get back to a schedule that makes sense for the life I have. All right. Awesome. Again, good night, Renardina, and good night, Lynn Swerve, and good night to anyone who I may have missed, and for anyone who may see this in the future, it is possible, I think. Whenever, wherever, whatever, however, just make the most of it. Okay. Bye bye.